Just in from the National Space Agency, Asteroid Apophis is coming back. NASA has devised a risky plan for looking into an asteroid in detail. Let's find out more. The scientific community and space agencies globally have increased their endeavors to investigate and comprehend near-Earth objects, or NEOs, such as asteroids, which present potential risks to our planet. Asteroid Apophis, in particular, has garnered significant interest due to its substantial likelihood of closely approaching Earth in 2029. To expand our comprehension of Apophis and formulate efficient measures of defense, NASA has developed a risky plan to dispatch the Osiris-REx spacecraft on an 18-month expedition to research this celestial entity. Moreover, in South Korea, smaller spacecraft like Apophis Pathfinder and potential private astronaut missions are also scheduled to investigate Apophis during the same period. We dive into Apophis's history and potential risks while examining NASA's ambitious strategy to research and protect against this upcoming asteroid. Asteroid Apophis, also recognized as 99942 Apophis, was initially detected in 2004 by astronomers at Kitt Peak National Observatory in Arizona. It attracted notice because of its substantial size, with a projected diameter of roughly 370 meters, or 1,210 feet. Subsequent evaluations alleviated worries about Apophis posing a significant risk of colliding with Earth when it comes close in 2029. However, further observations and improved orbital calculations progressively decreased the possibility of a collision, ultimately reducing it to nearly non-existent. NASA's Osiris-REx mission, which accomplished the remarkable feat of gathering samples from asteroid Bennu, is now preparing for its subsequent undertaking, analyzing asteroid Apophis. The Osiris-REx spacecraft is ready to collect important information on Apophis throughout its 18-month expedition, equipped with sophisticated tools such as cameras, spectrometers, and LIDAR. The ultimate goal of this mission is to thoroughly map the surface of the asteroid, explicitly emphasizing the detection of any alterations that might transpire due to its proximity to Earth. The Osiris-REx spacecraft, which stands for Origins, Spectral Interpretation, Resource Identification, and Security Regolith Explorer, possess distinctive capabilities to carry out detailed scientific examinations of asteroids. The spacecraft uses modern instruments to capture detailed images, study material properties using spectral analysis, and measure distances through LIDAR technology. The gathered data from these capabilities can offer valuable insights into Apophis's composition, structure, and geological history. The ultimate objective of the Osiris-REx mission is to generate highly intricate maps of Apophis's terrain. The spacecraft will capture images with exceptional resolution by employing its powerful cameras, enabling scientists to study the asteroid's topography, geological features, and potential surface changes. The mapping process will generate three-dimensional models, facilitating a holistic understanding of Apophis's form and composition. The maps provided will be of great value in comprehending the evolution and dynamics of the asteroid. The composition of Apophis will be analyzed using spectrometers and visual observations as part of the Osiris-REx mission. Spectrometers detect how light interacts with different substances, unveiling the existence of particular elements and compounds on the asteroid's surface. By examining the spectral characteristics of Apophis, researchers can distinguish the mineral compositions and gather valuable information about the asteroid's geological evolution. The compositional analyses of Apophis will provide insights into its origin, evolution, and correlation with other asteroids in the solar system. The Osiris-REx probe will utilize LIDAR technology to gauge the spatial gap separating it from the asteroid's surface. By accurately computing these distances, researchers can generate comprehensive topographic charts of Apophis, contributing to a more profound comprehension of its geography and possible alterations on its surface. These measurements will serve as valuable tools for detecting changes in the asteroid's shape or structure from its proximity to Earth. These modifications may suggest the Yarkovsky Effect, in which asymmetrical warmth from sunlight affects an asteroid's path in outer space. Comprehending the Yarkovsky Effect represents a notable goal of the Osiris-REx mission, undertaken by NASA, in investigating the asteroid Apophis. The Yarkovsky effect is where uneven sunlight heating causes a slight asteroid acceleration or deceleration, ultimately affecting its trajectory. Through analyzing the Yarkovsky effect on Apophis, experts can enhance their comprehension of the elements that impact asteroid movement and advance their capacity to foresee future trajectories and evaluate possible dangers. The Yarkovsky effect occurs due to the interaction between sunlight and the surface of an asteroid. The uneven heating of the asteroid's surface occurs as it absorbs solar radiation while orbiting the Sun. The asteroid experiences a recoil force due to the emission of absorbed sunlight as thermal radiation. This irregular heating process leads to a small force acting on the asteroid, altering its path from the predicted gravitational trajectory. The Yarkovsky effect's magnitude and direction rely on asteroid size, shape, rotation rate, composition, and thermal properties. All of these factors decide how solar energy is absorbed and released, ultimately impacting the strength and direction of the recoil force. Therefore, comprehending the Yarkovsky effect necessitates a comprehensive understanding of an asteroid's physical characteristics. Studying the Yarkovsky effect on Apophis allows scientists to enhance their comprehension of asteroid movement in space. Analyzing this effect with accuracy offers valuable information regarding asteroids' internal composition and thermal characteristics. Scientists use it to assess how solar radiation interacts with the asteroid's surface and redistributes heat within it. Such knowledge is of utmost importance to make accurate predictions of the trajectories of asteroids and evaluate the potential threats they might represent to our planet. The Yarkovsky effect is especially important to study for Apophis, since it will come close to Earth in 2029. The measurement's preciseness during the mission of Apophis will offer crucial data to improve future path predictions and risk assessment in subsequent flybys. Further exploration of asteroid Apophis in the upcoming years and NASA's Osiris-REx mission are being planned. The collaborative missions involving various organizations and countries reflect the worldwide commitment to researching Apophis and enhancing our comprehension of near-Earth objects. South Korea, preparing to launch its spacecraft, is undertaking a special mission to investigate Apophis. By analyzing Apophis's composition, scientists can learn about its source, creation, and development. Gaining knowledge about the physical characteristics of the asteroid, including its dimensions, form, and surface attributes, is immensely significant in comprehending its behavior and assessing any possible hazards. In addition to larger space agencies, smaller spacecraft missions are being created to explore Apophis. The Apophis Pathfinder, a task currently in development, has plans to launch between 2025 and 2026. While not as large as missions like Osiris-REx, these smaller spacecraft still contribute valuable data and perspectives on Apophis. They might bring specialized tools created to measure specific variables or concentrate on some regions of the asteroid investigation. These various missions collectively add valuable insights that enhance the overall understanding of Apophis and its unique attributes. Furthermore, there are intentions to initiate smaller vehicles, such as the Apophis Pathfinder, between 2025 and 2026. The compact spacecraft have been specifically designed to investigate Apophis, concentrating on its structure, internal composition, and surface characteristics. The data gathered by these missions will aid our comprehension of Apophis and potentially assist in formulating tactics to safeguard Earth from comparable asteroids. Additionally, there is a rising curiosity about potential private astronaut missions to investigate Apophis. These private ventures underline the importance of studying and thoroughly analyzing asteroids, including their composition, size, and trajectory. Secret missions can offer valuable data and discoveries, supplementing the continuous endeavors of space agencies and scientific organizations. Examining Apophis holds excellent significance due to a multitude of factors. It grants the chance to improve our comprehension of the characteristics and actions exhibited by asteroids that may present a danger to our planet. By examining Apophis at a close range, scientists can acquire significant knowledge regarding its makeup, arrangement, and susceptibility to breaking apart when approaching closely. This knowledge can be applied to enhance impact risk evaluations for additional near-Earth objects. Moreover, The examination of Apophis could contribute to the advancement of proficient protective strategies. After thoroughly analyzing the asteroid, researchers can assess different methods to reduce possible risks, like diversion missions or alternative intervention approaches. Grasping the Yarkovsky Effect holds tremendous significance in precisely forecasting the paths of upcoming asteroids and executing effective deflection methods if needed. Moreover, recent geological findings have emphasized the significance of scrutinizing asteroids near us. Geologists have found evidence indicating that the asteroid impact responsible for dinosaurs' extinction 66 million years ago was accompanied by another effect. This recently found impact site, the Nadir crater, provides significant knowledge about the intricacy of asteroid collisions and their enduring influence on Earth's geology and ecosystems. These findings emphasize the importance of researching asteroids and their potential effects on our world. Subscribe to this channel for more from the celestial realm. The intensive efforts to study and understand the potentially dangerous celestial object, Asteroid Apophis's upcoming close approach to Earth in 2029 has prompted. In conjunction with South Korea's proposed missions, smaller spacecraft like the Apophis Pathfinder, and potential private astronaut missions, NASA's ambitious undertaking demonstrates the shared dedication to acquiring a more comprehensive comprehension of Apophis and asteroids at large. These missions offer essential chances to examine the makeup, actions, and possible hazards linked with asteroids, creating efficient defense techniques and enhancing our comprehension of the formation and dynamics of the solar system. Moreover, current geological findings strengthen the significance of researching asteroids closely to understand their significant influence on Earth's past and future. NASA has made another chilling discovery, and this video will take you there directly. What is stopping you? Click now and we will see you there in a moment.